This is Dr.D Govardhan, Professor in Department of Aeronautical Engineering, Institute of Aeronautical Engineering, Hyderabad. Today the topic is the ladder friction. What are the forces that are acting on the ladder? Wind is about to slide, that is in equilibrium position. How they are related to each other. By analyzing the forces, we can determine the unknown quantities which are required as per the given problems. So before that one, first of all, we will discuss the free body diagram of ladder. Ladder is a device generally used for climbing or scaling on the roofs or the walls. It consists of two long uprights of wood or iron or the rope, which are shown in figure like this, and having number of cross pieces. These are called rugs, as shown in figure now. If the ladder is uniform throughout its entire length, then the center of gravity of the ladder will be the midpoint of its length. Here, assume this is the midpoint, the weight of the object is acting vertically downward directions. When the person is climbing in upward directions, at a certain point, assume it tends to slide downward directions. So, what are the forces that are acting on it? Since the edges here represented as A and B, A lies on the horizontal ground and B is on vertical wall. Since it is kept against the vertical wall, as shown in figure. Since the B end is moving in downward directions, the frictional force between the B point, which lies on the ladder, and the vertical surface is always acts in upward directions, which is shown as FB in the figure now. The normal reactions at B is again represented as NB. It is a perpendicular to the surface at the point of contact. And at A, since the body is when the ladder tends to slide downward direction, the end A always moves away from the vertical wall. Hence, the frictional force is always acts in opposite direction in which the points tends to move. Here, according to this figure, it is toward the right side. The normal reaction is upward. It's given now. Let alpha be the inclination of the ladder with the horizontal, and Wm assume represent the weight of the man when it is climbing in upward directions. At that point, assume it is in equilibrium positions. That means about to slide in downward directions. That is the forces which are acting on the ladder are now. The friction force Fe and Fb at A and B. Normal reactions Na and Nb. The weight of the ladder is always passed through its midpoint. And weight of the person. All these forces are coplanar but non-concurrent. Hence, while analyzing, we required three equilibrium equations, such as the algebraic sum of the forces which are acting along the horizontal plane or in horizontal should be equal to 0. The second equation, the algebraic sum of the component of vertical forces should be equal to 0. And third equation, the moments created by the component of forces at any point should be equal to 0 now. Here, according to this problems, at A and B, two unknown forces are there, Fe and Na. At B, Fb and Nb are there. Hence, while taking the moments, A or B points are treated as most suitable. Now I am taking one problem now. Okay, this is the figure is representing the free body diagram of the ladder now. Fb acting upward directions, Nb is acting perpendicular, mg the weight that in downward directions, and w is representing weight of the person. Now Fe and Na at A friction force normal reactions. According to the first equation sigma Fx is 0, we are having Fa minus Nb should be equal to 0. The second equation is sigma Fi is equal to 0. That is Na is acting upward directions, Fb is acting upward directions, but the weight is acting downward directions. Now that is it should be, that is Fb plus Na minus of W should be equal to 0. The third equation is the algebraic sum of the moments about any point, that is we are taken here Ma, it should be equal to, that is Nb is here we are not taking, when the moments are taking, the moments created by the forces in anti-clockwise direction are treated as positive, and clockwise direction we are taken negative. Based on the equations, Fb into B plus Nb into H minus half Mg into, since midpoint, L by 2 cos alpha, which should be equal to 0 required. Okay, these are the fundamental equations that are now required to analyze the forces on the ladder. Now I am taking here one problem. A ladder 5 meters long rests on horizontal ground and leans against a smooth vertical wall at an angle of 70 degrees with the horizontal. The weight of the ladder is 900 newtons and at its middle, the ladder is at the point of sliding. When a man weighing 750 newton stands on a rung 1.5 meters from the bottom of the ladder, calculate the coefficient of friction between the ladder and the floor. Now in this problem, so the vertical wall is smooth, hence the force of friction between the vertical wall and ladder is 0. That means Fb is equal to 0. Only at B it is having normal reactions now, at B now. So the forces are now frictional force at A, Fa, normal reactions in A, in B, normal reaction in B. The weight of the person is 750 newtons and the ladder weight is 900 newtons. Both are acting 9 downward directions. These are the forces are acting on it, and the body is in equilibrium position. Since the forces are coplanar and non-concurrent, hence 3 equations are required to satisfy the equilibrium condition. Okay, the given data in the problem is length of the ladder is given 5 meters. The angle which the ladder makes with the horizontal is given 70 degrees. The weight of the ladder is given 900 newtons. Weight of the man is given 750 newtons. The distance between the man and bottom of the ladder 1.5 meters. Na is representing normal reactions at the floor. That is the point at A. Now, Fa is representing frictional force point at A. Now, regarding the forces, when you are taking Nb, at B there is no frictional force, Na and Fa, and the weight of the man, which is at a distance of 1.5 meters from A point, and weight is acting at its midpoint, that is 2.5 meters from A, which is represented in a figure now. Now resolving the forces horizontally. In horizontal only 2 forces are acting. Frictional force at A, which is acting toward the right side, it should be equal to the normal reactions at B, Nb toward the left side, or Fa is equal to Nb as shown in figure 1 now. Resolve the forces vertically, that is Na is acting upward directions, 900 plus 750 is acting downward directions, hence this is equal to Na is equal to 1650 newtons as shown in equation number 2 now. Hence, force of friction is equal to Fa is equal to mu Na. That is, mu A is given. We have to determine that values mu A into 1650. It is the equation number 3 now. Now, taking the moments about a point A and equating the same, that is the sum of the moments created by the forces in anti-clockwise direction should be equal to the moments created by the forces in clockwise directions. Here NB is now creating anti-clockwise direction moments, but the weight as well as the weight of the man both are tends to rotate the ladder in clockwise directions. Hence both should be equal. From these equations we got NB into H is equal to the ladder length is given 5 meters, inclination is given 70 degrees. Hence H is equal to 5 into sine 70. That is NB into 5 into 770. This is the moments acting towards anti-clockwise directions. It should be equal to 750 weight of the person 1.5 into cos 70 plus 900 into this is the weight of the body of the ladder 2.5 is acting in the middle into cos 70 degrees now. From this relationship we got NB is equal to 1849.25 newtons is shown in slide now. Now FA is equal to NB. Here NB is equal to 675 divided by tan 70, which is equal to 675 divided by tan 70 is equal to 2.74, 246.35 now. But FA is equal to mu A NA, which is equal to mu A is equal to mu A into 1650, which is equal to 246.35 divided by 1650, which is equal to 0.15. Okay, second problem now. A uniform ladder of 4 meters length rests against a vertical wall with which it makes an angle of 45 degrees as shown in figure. The coefficient of friction between the ladder and the wall is 0.4. That is mu B is equal to 0.4 is given, and the between ladder and the floor is given 0.5. That is at A is equal to 0.5 is given. If the man whose weight is 1/2 of that of the ladder ascends it, how high will it be when the ladder slips? Now the given data is length of the ladder is given 4 meters. The angle which the ladder makes with the horizontal is given 45 degrees as shown in figure. Coefficient of friction between the ladder and the wall is given at B 0.4, which is represented as mu B. Coefficient of friction between the ladder and the floor is given 0.5. Let X be the distance between A and the man when the ladder is at the point of slipping. W is equal to weight of the ladder and N is the normal reactions at the floor, that's the point at A, and the weight of the man is given half of the ladder, which is equal to W by 2, which is equal to 0.5 W. Now, the frictional force at the floor is equal to Fa is equal to mu A Na, which is equal to 0.5 Na. This is the equation number 1. The frictional force at the wall is equal to mu B NB, which is equal to mu B is equal to 0.4 into NB, is given in equation number 2. Now, by considering the system is in equilibrium position. This applying equilibrium equations such as sum of the component of forces which are acting in a vertical direction should be equal to 0 and in horizontal direction should be equal to 0, and the moments created by the forces at any given point should be equal to 0. These three equations we are applying. The first one is resolving the forces vertically. The vertical forces in A is acting upward directions. The weights are acting downward directions, and FB is also acting upward directions. So, hence, NA plus FB both are acting upward directions. So, the weight of the ladder and weight of the person is acting downward directions. So, which should be NA plus FB is equal to 1.5 W, which is shown in equation number 3rd. Similarly, resolve the forces horizontally. The NB is acting toward the left side, FA is acting toward the right side. Hence, NB is equal to FA, which is equal to FA is equal to NB, but NB is equal to, we are having 0.5 NA, FA is equal to 0.5 NA, or NA is equal to 2 into NB. This is the relationship we got it now. Now substitute the values of NA and FB in equation number 3. We got 2 NB because NA is equal to 2 NB is given now, plus 0.4 NB, which is equal to 1.5 W, or 2 NB plus 0.5 NB is equal to 2.4 NB. It is equal to 1.5 W, or NB is equal to 1.5 divided by 2.4 W, which is equal to 0.625 W. Similarly, FB is equal to 0.4 NB, which is equal to 0.4 into NB is given 0.625 W, which is equal to 0.25 W, which is represented in equation number 4. Similarly, taking the moments about a point A and equating the same. So, at A is mean nothing but what are the forces are there? The NB is it tends to rotate the body in anti-clockwise directions. Similarly, the FB is there, again it is acting upward direction, which tends to rotate the body in anti-clockwise directions, and the weight of the man as well as the weight of the ladder tends to slide in clockwise directions. Here now we are taking the sum of the movements in clockwise direction should be equal to the sum of the movements in anti-clockwise directions. Okay, according to that condition, we got to W into 2 cos 45 degrees plus 0.5 W into X, because the position of man when the ladder is about to slide, we assume as X, hence X into cos 45, which is equal to NB into 4 sin 45 plus FB into 4 cos 45. Substitute the values of FB and NB. We got W into 2 cos 45 plus 0.5 W into cos 45, which is equal to 0.625 W into 4 sin 45 plus 0.25 W 4 cos 45 now. Now divide the equations on both sides by W sin 45. Because W is a common term now, we got 2, here it is gone now. Now 2 into cos 45 by, here we got 2 plus 0.5 x, since sin 45 is equal to cos 45, and so we got this is equal to cancel, it is also cancelled, this is also cancelled, it is also cancelled now. So the remaining terms are 2 plus 0.5 Wx equal to, here 4 into 0.625 is equal to here 2.5 plus 0.5 into 4 is equal to 1, which is total is equal to 3.5 now. Hence x is equal to 3.5 minus 2 divided by 0.5, which is equal to 3 meters. That is when the person is climbing by using ladder, when you move at a distance of 3 meters, the ladder tends to slide in downward directions. Okay, this is our required answer. Okay, now taking one more problem. A uniform ladder of 3 meters long weighs 200 newtons. It is placed against a wall making an angle of 60 degrees with the floor as shown in figure. The coefficient of friction between the wall and the ladder is 0.25 and between the floor and the ladder is 0.35. The ladder, in addition to its own weight, has to support a man of 1000 newtons at its top. That means at B, which is shown in figure now. Now, calculate the horizontal force P required to the ladder at the floor level to prevent sliding. At this point, how much force we have to apply to prevent it sliding. The first case. The second case is if the force P is not applied, what should be the minimum inclination of the ladder with the horizontal so that there is no slipping of it with the man at its top. These two conditions attest to such phenomenon. So the given data is in this problem, length of the ladder is given 3 meters, weight of the ladder is given 200 newtons, which is always acts in the midpoint of its length. The coefficient of friction between the wall and the ladder is given 0.25. The coefficient of friction between the floor and the ladder is 0.35. The forces acting on both sides, on both the cases, are shown in figure A and B now. Now, case 1. Consider the ladder is inclined at an angle of 60 degrees to the horizontal and subject to the horizontal force P at the floor, which is shown in figure, to avoid the slipping when the person is at B, as shown in this figure now. Now, in this case, we have to determine the force P now. Let horizontal force P applied to the ladder at the floor level to prevent sliding be taken. Now, the free body diagram is represented in A, in which at A point, in A is the normal reaction upward directions. Here, preventing slipping means nothing but the point A moves towards the left side. Hence, FA is acting towards the right side. P force is also applied towards the right side. And at the top, normal reactions NB is acting horizontally toward the left side. Friction force is acting upward directions. The man weight is acting downward directions. At the same time, in the middle, the weight of the ladder is acting downward directions, which are represented in the figure. Now, resolve the forces horizontally. P plus FA should be equal to NB, which is represented as equation number 1. Resolve the forces vertically. NA plus FB, which is equal to 1000 plus 200, is equal to 1200 newtons. Now, taking the moments about A and equating the same, the 200 into 1.5 cos 60 plus 1000, that is weight of the person, is given into cos 30, which should be equal to FB into 3 cos 60 plus NB into 3 sin 60, which are shown in equation. Dividing both sides by the cos 60, we got 200 into 1.5 plus 1000 into 3, which should be equal to FB into 3 plus NB into 3 tan 60 degrees. From this equation, we got 1100 is equal to FB plus NB tan 60. But FB is equal to mu into NB, which is equal to mu is given 0.25. By substituting the values of FB in equation number 3, we got 1100 equal to 0.25 NB plus NB tan 60, which is equal to NB into 0.25 plus 1.732, which is equal to 1.892 into NB now. Or NB is equal to 1100 divided by 1.982, which is equal to 555 newtons. Similarly, FB is equal to mu NB, 0.25 into NB, that is 0.25 into 555, which is equal to 138.7 newtons. Now substitute the values of FB in the equation number 2. NA plus 138.7 equal to 1200. Or NA is equal to 1200 minus 138.7, which is equal to 1061.3 newtons. FA is equal to mu NA, it is equal to 0.35 into 1061.3, which is equal to 371.5 newtons. Now substitute the values of FA in equation number 1. We got to P plus 371.5 equal to 555, or P is equal to 555.371.5. This is equal to 183.5 newtons. This force should be applied at a point P at A in horizontal position to prevent the sliding. When a person is at B position, that means at the top of the ladder as shown in figure. Now case 2. In this case, we have to determine the inclination of the ladder to prevent the sliding. When the person is at B as shown in figure B now. Now resolve the forces again horizontally. That is NA is FA is equal to NB as usual, like in previous case now. The second one is resolve the forces vertically. NA is acting upward directions. FB is acting upward directions. The weight of the persons is acting downward directions. And the weight of the ladder acting downward directions. Hence, NA plus FB should be equal to 1200, which is shown in equation 5 now. We know that FB is equal to mu NB, which is equal to 0.25 into NB, but NB is equal to, according to the first equations, FA is equal to NB, we can write it as mu NA, that is FA, which is equal to 0.25 into 0.35 NA now. This is the relations what we got now, which is equal to FB is equal to, we can written as 0.09 NA. Now from equation number 5, we got NA plus 0.09 NA is equal to 1200 newtons. Hence 1.09 NA is equal to 1200. NA is equal to 1200 divided by 1.09, which is equal to 1101 newtons. Hence NB is equal to FA is equal to 0.35 NA, which is equal to 0.35 into NA is equal to 1101, which is equal to 385.4 newtons. Similarly, FB is equal to 0.09 NA, which is equal to 0.09 into NA is equal to 1101, which is equal to 99.1 newtons. Okay, these are the values we got it. Now taking the moments created by all these forces at a point A is given by, and applying equilibrium condition, that is the sum of the moments which are acting in clockwise direction should be equal to the anti-clockwise directions. Based on the equations we got, that 1000 the person is, that is it tends to slides in clockwise directions, that is 1000 into 3 into cos alpha, plus the weight of the person is it is there, it tends to slides again in clockwise directions, that is 200 into 1.5 cos alpha. It should be equal to the moment created by the frictional force as well as the normal reactions at B, both tends to slides in anti-clockwise directions, that is FB into 3 cos alpha plus NB into 3 sin alpha. Dividing both the sides by 3 cos alpha, we got 1000 into 1000 and plus here 200 is there now. It becomes 100 because here we are taken 3 now. It should be equal to FB plus NB tan alpha. From this relationship, we got 1000 equal to 99.1 plus 385.4 into tan alpha. By using the equations, tan alpha is equal to 1000.9 divided by 385.4, which is equal to 2.5970, or alpha is equal to 68.9 degrees as shown in figure. That means when the inclination of the ladder is 69.9 degrees, the position of the person is at B position, then at that moment only the ladder tends to slide in downward directions. Okay, this is the conclusions of what we got from this one. I think yes, we are understanding what are the forces that are acting on the ladder and how can we analyze the forces and everything. Still, if you are having any doubts, better to contact me. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.